For lesson 5.1, we're going to be looking at systems of equations. And we're going to learn several different ways to solve these, but our first way is we're going to solve them by graphing. So we're going to use a skill we just learned or reviewed in 5.0. First, a linear system is just two, or it could be more. We're just going to focus on two for right now, but it could be more. We're talking about just linear for right now, so straight line equations, and they are solved together. So that means they both have to be true. So we're looking for an answer that is an answer for both equations at the same time. So then the solution, graphically, it looks like the ordered pair where the lines cross. So again, graphically, the solution is where do the lines cross or intersect. Algebraically, it is a ordered pair that satisfies both equations. And what that means is that it makes both equations true. So I could plug in the x and y for each equation and it's going to be correct answer. All right, so I'm going to write down some steps off to the side that might be helpful if you want to write these down for yourself as well. So first, to graph. The first thing we're going to want to do is write any equations in slope-intercept form. And some are already there, but some won't be. Then we're going to graph each equation separately. Make sure you graph them on the same graph. We graph each equation on the same graph. And then we're going to look for where they cross. And we're going to look at some special cases, but not until once we've learned how to do all this first. All right, so now let's look at an example. So number one, we already have both equations in slope-intercept form. So I'm just going to go ahead and graph both of those equations. So let's make this equation number one, we'll graph that in red. So my y-intercept is -3. My slope is +1 over +2. So I'm going to go up 1 and right 2. And I'm going to keep going up 1 and right 2. I could also make that the equivalent slope would be -1 over -2. So I can go -1 and -2, -1 and -2. And we want these lines to be as straight as possible. So that's why I'm going to make extra points for my slope. And we graph the other line. Let's make this line number 2 in blue. The y-intercept is 4. So I'm going to start up here where the y is 4. Our slope is -3 over 1. So down 3, 1, 2, 3, and +1. Down 3 and +1. So it's right on top of the other point we already had. And then we draw our line. So the point where these two lines intersect is this point right here. Assumed I could draw my lines straight. And that is the ordered pair 2, -2. So we went right 2 and down 2. So then that is the solution to both of equation number 1 and 2. So then they're solved together. And then it also says in the directions here, then check your solution. I'm not going to do this on the video for every problem, but I do want us to see how we could check our answer. So let's go back to the equation number 1. Since that one was red, we'll make it red again. So equation number 1 was y equals 1/2 x minus 3. So to check our work, we're going to take the solution we found where x is 2 and y is -2, and we're going to plug that in. So the y was -2, so we're going to plug in -2 for the y. then we have 1/2 times, then the x number. The x we got +2, so +2 goes in for x. Then we still have the -3. And then we're just going to simplify each side. So the left-hand side is already simplified. That's just -2. On the right-hand side, -1/2 times 2, and that's 1. Then I still have -3. Again, the left-hand side is already simplified. It stays -2. On the right-hand side, 1 minus 3 is -2. And then you want to check, is this a true statement? Is -2 really equal to -2? And it is, so our solution worked. And then we would want to verify that it worked for the other equation also, because it has to be an answer for both. So that was equation y equals -3x plus 4. And then again, we're going to plug in our y number was -2. And then we have -3 times x, but our x number was 2 that we found. And then we have plus 4. So we're going to simplify. -3 times 2 is -6. And we still have that plus 4. -6 plus 4 is -2. And yes, -2 does equal -2, so that is also correct. So now we know that it's a solution because it works in both equations. It is a bit of work, but if you have extra time on a quiz or test especially, take the time to double check your work and make any corrections needed. All right, let's look at number 2. So again, these are already both in slope-intercept form. For the first equation, our y-intercept is a +3, and our slope is -2 over 1. So -2, +1, -2, +1. I'm going to keep going so I can make my line nice and straight. And then for my other equation, got in the way there, my other equation, it's y equals x. Well, if there's no slope, that means it must be a 1. And if there's no y-intercept, it means it must be plus 0. So our y-intercept is 0. Then our slope is 1 or 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, and so on. And I can also go the other direction. And we draw our line. And we look for where do the 2 points, or the 2 lines intersect. Right here at the point 1, 1. So our solution would be 1, 1. It's the answer that works for both equations at the same time. And again, we could plug in like we did in number 1. We're just not going to do that for this example. Okay, number 3. On number 3, neither equation is in slope-intercept form, so we have to rewrite both of those equations. So let's do this equation first. So that's going to be 4x minus y equals -1. And we are going to rewrite that. So minus the 4x, we always want to do the opposite. Don't forget to bring down that minus sign with the y. And then really that means it's -1. And then over here we have a -4x and a -1. And then everything has to get divided by -1. So we end up with y equals +4x plus 1. Let's go ahead and graph that one. So my y-intercept is +1. My slope is 4, or really 4 over 1. So we go up 4 over 1. Or I could go the opposite. The opposite would be, so +4 over +1 is equivalent to negative over a negative, because 2 negatives make a positive. So I can go -4 and -1. It's going to make my same line. Okay, and then we'll do the other equation. So that one was that 2x plus y equals -5. We're going to minus 2x from both sides. We end up with y equals -2x minus 5. So our y-intercept is -5. Our slope is -2 over 1. So I can't go down 2, so we need to use our equivalent slope. So the equivalent slope to -2 over +1 is +2 over -1, as long as there's one negative sign. So I can go +2, -1. There's our point. +2, -1, and so on. I'll draw my line. And then the solution is that point where they crossed, and they crossed at the point -1, -3. even if you can see where that point was going to be, make sure you finish graphing both of your lines. Okay, and then our last one. So we've briefly talked about these special lines a little bit in the last couple chapters, so let's just review that again. If the equation is x equals, that means it's going to be a line that only goes through the x-axis. So for that to happen, it's going to be a vertical line. So this is our vertical line. It's going to be a vertical line through the -3. So here's where x is -3. Then we draw a vertical line. Then for y equals, that's the horizontal line. And it's going to be where y is 4. So that's up here where y is 4, and then we draw a horizontal line. And if we extend this one a little bit, we can see the point where they cross is going to be right here. And that is at the point -3, 4, which we can actually see here is -3, 4, because those values will never change. And again, we will learn other ways to graph, or to solve systems of equations. Graphing is one method. And really, graphing is not the best method. All the answers we had were whole number or integer answers. But if the lines crossed in the middle, then with some kind of decimal answer, we would have to estimate the solution. And we can't have an estimated solution. We need an exact solution. So the next couple lessons are going to be different ways to find those exact solutions when that happens.